I explained how to find out if you have a function. If you have an x value, let's say these are my x's, 3, 4, 5, 6, and these are my y's. And let's say that you have some function, some equation that you're putting these numbers in, and they spit out these answers. Notice when I put in a 3, I get a 5, 4, I get a 6, 5, I get a 7, 6, I get an 8. Okay, that's a function because they're only going to one number. Now, if, for example, I put in a 3 and I got a 5, like right here, but let's say I put in a 3 and it also gave me a 6. Now I'm putting a 3 in the machine and it's given me two different answers. That means that it's not a function. Okay? So if I've got a list of numbers, a list of x's and a list of y's, and I'm trying to decide if they're functions or not, I might write them like this. 1 corresponds to 3, 2 corresponds to 5, and 4 corresponds to 1. Okay, meaning that when I put 1 in, I get a 3 out. I mean, this is my x, that's my y. You know, it's just graphing like we normally do. You get a 1, you get a 3. You get a 2, you get a 5. You get a 4, you get a 1. Okay, you can graph those points. But this is the x, and it spits out a y. This is the domain, spits out a range. Okay, same way here. X gives you a y, and x gives you a y. Alright, so when you're given a list of these like this, one way you can tell if they're functions just by looking at that list is as long as x's are not repeated, then it's a function. If, for example, I had 1, 3, 1, 4, and -1, 6, notice I have a 1, I put in the machine, it kicks out a 3. I put in a 1, put it in the machine, it kicks out a 4. I can't put a 1 in and get two different y values. Not happening. So if you're given a list of coordinates like this, this, and this, and your x's repeat themselves, then that is not a function. Okay? So again, the domain is the first number, the number you're putting in the machine, the x value, and the range then will be what you get out of it, the y values. So if you look at your homework assignment, number 4, for example, notice how the x value is well, they give you 3, -4, -1, 5, and 3, 2. Notice how the 3 shows up in the x position twice. The first set of numbers and the second set of numbers. That means it's not a function. You cannot have an x value that repeats itself. Y values can repeat themselves all they want, but x values cannot repeat themselves. Alright, so what if, alright, so that's the way to tell if it's a function when they give you coordinates like that. What if they give you a graph and they say, is that graph a function? Well, there's a real quick and easy way to tell if it's a function. You just start drawing horizontal or vertical lines like this. And if you can draw a vertical line all through the graph and it only intersects the actual graph, this orange here, in one place in the whole thing, then it's a function. If, on the other hand, you have this here and you've got your graph and it goes like this and then maybe like this, which some graphs do, and you do your vertical line, only intersects one place, but notice in these places it intersects in 3 different places. So that means this line, this graph, this orange one I have here, is not a function. So just by looking at it, if you can draw a vertical line and it intersects your graph in more than one places, it's not a graph. So if I have a parabola like that and I draw my vertical lines, yep, only intersects one place. But if I have something that goes like this and I draw a vertical line, it intersects it in 2 places, so that is not a function. So that's how you can tell in numbers, let's see, 11 through 20. You can tell that whether they're functions or not based on whether or not you can do that vertical line test and they cross. Alright, one more part of this and then we'll be done. If you look at numbers 21 to 24, it's saying determine the domain and range of the following functions. Alright, so if you remember, well, let's look at 22. Okay, and this goes to 2, and this goes to -2, and this is 3, and this is -3. Okay, so the domain means how far to the left or right does the x value go? Well, it stops at -2 and it goes to +2, right? Doesn't go any further. Okay, so what you would do is you would write -2 is less than or equal to x, which is less than or equal to 2. Okay, so you'd write something like that. Okay, that shows that the domain, the value for x, is somewhere between here and here. Doesn't go further. It stops there and there. Doesn't go past 2. Now let's look at the y value. The y value goes up to 3 and down to -3. So we write it the same way. -3 is less than or equal to y, because we're talking range now, and range is y, and goes up to 3. Okay? And some books write it as, so this one here, some books write it as y such that y, or I'm sorry, I want to put that y there. Y such that -3 is less than or equal to y, which is less than or equal to 3. Some books might write it like that, and they would write the domain as set x such that -2 is less than or equal to x, which is less than or equal to 2. Alright, so again, the range shows you where the x possible numbers are. They're all numbers between here and here on the x-axis. And the y are from here down to here. Now sometimes when you're given a graph, it may go into infinity. It may do something like a graph might go start here and go like that. So let's say that's -6. So it starts at -6 and goes to infinity. Okay, it wouldn't have an equal sign because you'd never get there. It could not be infinity. But it doesn't look like any of these go into infinity. It looks like they stop. But anyway, if they did go to infinity this way, which as you get into higher level math, you will have some that do that, you just write infinity there, that it just goes on and on and on forever. Okay, so that's it for lesson 8.3.